Okay, we're going to start with example 2 from lesson 9 on projectiles. This is how we handle a problem where our object is launched at an angle from the horizontal and not completely horizontal. So we're starting with a ball is projected at an angle of 37 degrees up from the horizontal with a speed of 20 meters per second. And the first question to answer is, what is the maximum height of the ball? So step 1 in any type of problem involving vectors is to make sure that you separate any vectors that are not horizontal or vertical into their vertical components. So we're going to start with that diagram. So here's our 20 meters per second at an angle of 37 degrees. And we want to draw the triangle for the two sides. So I'm going to find the horizontal component of the velocity. Let's call that Vx. And the vertical component of the velocity, and let's call that Vy. So we're going to use our trig functions to find out the size of these two sides. Vy, the size of Vy is given by V times the sine of theta when it's measured from the horizontal. This is my vertical side, so it's going to be 20 meters per second times the sine of 37 degrees, and that's going to make it, and make sure you check that you're in degree mode before you do these calculations. We're good. 12.04. I'm going to write down horizontal is by V cos theta. So that's going to be 20 meters per second cos 0.9 meters per second. All right, now that I have my two sides, I'm solving and that question. So let's put down everything we know about the vertical direction. We know that we have an initial velocity upwards of 12.04 meters per second. We know that the acceleration due to gravity is in the negative direction, 9.81 meters per second squared. We're looking for the maximum height, so we need to have a displacement in our formula, and we need one more known variable. Well, this is one of the cases where you want to take advantage of the stuff you just have to know, and that is at the highest point in our trajectory, the ball immediately has a velocity of 0 for an instant. So we're going to use that value of V2 being 0 meters per second at the highest point. Okay. And then we can choose a formula to solve for d, and we notice this is the formula that does not have t in it. So let's go ahead and solve that. So V2 squared equals V1 squared plus 2AD. And our d then, once we eliminate V2 as being 0, is going to be the negative of V1 squared all over 2A. So the negative of 12.04 meters per second all squared divided by 2 and divided by negative 9.81 meters per second squared. It's important that you force this multiplication to happen before you do the division overall. So let's calculate that. 12.04 squared also negative, and we get 7.88 and so on meters. So to a total of 2 digits from my original information, I'm going to record meters. Now, completely by vertical information, because it was a question only about the vertical direction, how high, and so we don't need to go on and do anything further.